Hello there, ladies and gentlemen. We are now in 6-6, Systems of Inequalities. So this is going to be some review of 5-6. Basically, the only difference between an inequality and equation is what? Equation has an equal sign. Inequality has either greater than, less than, greater than or equal, or less than or equal. So here is a system of inequalities that we have. This is example 1 on page 372 of your text. We have y is greater than negative 2x plus 1, and I've got to draw this in. I can't do it in my program. And y is less than or equal to x plus 3. So the first thing I have to do, I have slope-intercept form. I have to graph both of those lines. So I've got y is greater than, I'm going to graph the first one first. Y is greater than negative 2x plus 1. So I know my y-intercept is at 1 right there, and I know I'm going to go down 2 and over 1. Down 2, 1, 2, and over 1. So this line, now I need to know whether my line is going to be dashed or whether it's going to be solid. Well, since I do not have the equal sign, this line is going to be dashed. So I'm going to go down here like this. And it's not perfect on my device, but you get the picture here. So that is the first line. Y is greater than negative 2x plus 1. And the next line, y is less than or equal to x plus 3. So I know I'm going to put this in a different color. I'll pick blue, and I know that my y-intercept is at 0, 3. And then I go up 1, right 1, up 1, right 1. And this one is going to be a solid line. Why is it a solid line? That's right, because it's less than or equal to. Okay, now I have to shade the correct ways. So I only drew the lines. I did not do the shading before, so I'm going to do the shading. Now, in your book, it'll show shading in different colors. A lot of times what people do is they make lines going different directions. I'll show you that. So first, my first line, it's going to be everything y is greater than negative 2x plus 1. So is that everything to the right of the line or everything to the left of the line? Everything above the line or everything below the line? Well, it's everything above. So I'm going to shade this way, like this. Okay? And then the next one is y is less than or equal to x plus 3. And I'm going to change back to my blue. So is that below the line or above the line? Well, this one is below, so I'm going to shade this way. And you see what happens is we get this nice cross-hatching pattern. Okay? And this is the place where it overlaps. So this area right here, which I will outline in red, this area is actually the solution, and even this part of the line right here, this is our solution, that area that is crossed over. So if you want to do that by cross-hatching like I did, if you want to shade in the area, only the area that overlaps, that's fine also. But that is our solution, because that is something that can be in both of the equations. So let's do another example. So here is example 1a, or actually guided practice 1a on page 372. We've got y is less than or equal to 3. Well, that one is pretty easy. So I don't have any x in this one, so it's just going to be a horizontal line. My y-intercept is at 0, 3 right here. And since it can be equal, it is not a dashed line, it's a solid line. So I want everything that is less than that, so that's everything down here. So I'll just shade that in. And then I've got x plus y is greater than or equal to 1. Well, they're not being nice to me here. I need to put it in slope-intercept form, but that's easy enough. I have to get y by itself, so I subtract x from both sides, and I get y is greater than or equal to negative x plus 1. So I know that my y-intercept is at 0, 1, so I'm going to draw that right here. And I have negative x. My slope is negative 1, so I go down 1 and then right 1. I go down 1 and then right 1. And so my line is going to be like this. And it's not exact there. You can see I didn't quite line it up, but it's close enough. So I want everything that is greater than that. So everything greater is up here. And now you see the section where I get the cross-hatching, so I'm going to shade that in a different color, and that is my solution for this system of inequalities. Notice, with systems of inequalities, the only way that we are solving them is by graphing. I mean, if you'd really want to, you could do one of the other methods that we use, but man, that can get really hairy. So we'll just solve these by graphing right now. Alright, this will be my last example. This is example 2 on page 373. We have 3x minus y is greater than or equal to, and 3x minus y is less than negative 5. Well, once again, they do not give us slope-intercept form. They don't on either of them. So first let's solve for slope-intercept form. I'm going to solve the first one for slope-intercept form. So I'm going to subtract 3x from both sides, and I get negative y is greater than or equal to negative 3x plus 2. Now, I don't care what negative y is greater than or equal to. I care about y. So I have to multiply or divide by negative 1. Doesn't matter which one I do in this case. But remember the thing about inequalities. When you multiply or divide by negative 1, you have to flip the sign. So I get y is less than or equal to 3x minus 2. I have to multiply everything on both sides by negative 1. So I went from y to negative y, I went from negative 3x to 3x, and I went from 2 to negative 2. So I also have in the second equation, in the second inequality, I'm going to go negative y, I subtract 3y from both sides to get negative y is less than negative 3x minus 5, and once again, I multiply or divide by negative 1, whichever you prefer. It does the exact same thing, you just flip the signs. And I get y is greater than 3x plus 5. So once again, I multiply by negative 1, so I get from negative y to y, from negative 3x to 3x, from negative 5 to 5. So these are my two equations right now, or my two inequalities. I'm sorry, I should not use the wrong terminology. These are my two inequalities, so let's graph them. I have them in slope-intercept form now, so let's start graphing. In my first one, I have a y-intercept of negative 2, that's right down here, and I have a slope of 3. So I go up 3, 1, 2, 3, and over 1. 1, 2, 3, whoops, 1, 2, 3, and over 1. And it's going to come up like that. And this is not perfect because I don't have the precision that I need with this. But it's going to be a solid line, so it's going to come down like this. And I want everything underneath it because it's less than or equal to. So I'm going to shade everything underneath it. There we go. And then my second one. My second one is going to be y is greater than 3x plus 5. So I'm going to have my plus 5, my y-intercept of 5 is right here. And everything greater than, so I'm sorry, I've got to do the slope. Slope of 3, up 3 and over 1, up 3, 1, 2, 3, and over 1. And this one is going to be a dotted line, so I'll dot it there. And then I want greater than, so I want everything above it. So that's going to be right here. Now what do you notice about that? This is strange. They never intersect. So what does that mean? It means we bring back our old friend no solution. Because the solution, if there was a solution, it would have, you see in here, in this section here, that's where an overlap would have to be, but there's no overlap because this all goes over here and then this one all goes down here. They never overlap, so there are absolutely no values of x and y that are in both of these equations. So there is no solution.